Hello everyone, I have some microwave demonstrations here to show you wave phenomena using microwaves. I've got a microwave receiver and a microwave transmitter, which you can see. The transmitter's emitting microwaves, the receiver receives them, and I've got it plugged into a loudspeaker so we can actually hear a sound whose loudness reflects the intensity of microwaves being received. Okay, so what can we do first? Well, let's do reflection first. If I turn the transmitter so that it's emitting microwaves in that direction, and we've got the receiver looking for microwaves coming at it from here, if I put a metal sheet here, we should be able to get reflection off that metal sheet. You can see, roughly speaking, I'm not going to do any precise measurements, but the angle of incidence is equal to the angle of reflection here. If I take that away, the receiver gets nothing. Okay, so that's reflection. Next, polarization. So, the waves that are being produced by the transmitter here are polarized, and I can prove that to you because if I rotate it through 90 degrees, watch, the receiver now receives no intensity because the receiver also has its own polarization axis. It can only detect microwaves polarized in a certain direction. What that means is that I can use a polarizer, which in this case is a metal grid like this, to investigate how the polarization, or in which direction the polarization is. So if let's put it first of all so the metal slats are horizontal, microwaves are still getting through. If I put it vertically, the microwaves are now not getting through this polarizer. Okay, so you might like to think therefore which direction of the microwave is the electric field of the microwaves oscillating in. Is it vertically or horizontally? I'll leave that one for you to work out. I might reveal it at the end. Notice I can also rotate this to change the intensity. You can see here the changing intensity of the sound coming from the loudspeaker as I rotate this. So you could do a quantitative investigation. You could do a quantitative investigation of Malice's law using this setup. Okay, let's just get rid of that sound for a minute. Next, refraction. Now, unlike visible light, which you'd use a glass prism or glass block or lens, with microwaves, what I want to try is using this. Okay, next, what I'm going to do is I'm going to look at refraction, and we're going to use a wax block instead of a glass block for microwaves. So you can see that I've got the transmitter, the receiver raised slightly on these two bits of these box lids, and you can hear the signal. If I put the prism, now this is a convex surface, this side's flat, so I'm going to put this in front of the transmitter, and it's now going to reduce the intensity against the receiver. Obviously it's blocking it to some extent. However, if we think, well, the microwaves can get through the wax, if this is a convex lens, what's going to happen is the microwaves are going to go in, but they're going to be refracted in that direction, okay? Because they're going to change direction, bend towards the normal on entry, right? And they're going to bend away from the normal on exit, but the net effect is they're going to end up coming out more in this direction. So watch this. You can hear the intensity of the sound is higher now, round about here, than down there. So the lens is having the desired effect, it's refracting the microwaves. Okay, let's put that wax lens back. Next, interference. So, first setup for interference is going to be double slit. So what I'm going to do, I've got a middle slit here, and I'm going to put two metal plates either side, like this. Now, the wavelength of these microwaves is of the order of centimetres, so to get appreciable diffraction, we want a slit's width of about on the order of centimetres. So what I'm going to do, might need a bit more space, is place the two slits like so. Now, let me show you, hopefully you can see that. The slits here, about a couple of centimetres. There we go. So now, what we expect is, we've got transmitter emitting microwaves in this direction. Let's see what we hear as I move, let's move this speaker further this way. Let's listen to what we hear as we move the receiver across the table. Oh, listen carefully. So you can hear that. Nothing. Intensity. Higher intensity. Goes to nothing again. Central maximum. Nothing. Do I have space? There we go. There's the other maximum. So I'm getting a fringe pattern in this region because of the two-slit interference of the microwaves. Okay, here's another one for you. So I've got the same setup as I had at the beginning. So transmitter, detector, metal screen to reflect. Okay, so without the metal screen there, nothing. So we're getting microwaves being reflected off this metal screen. Now, I'm going to use this wooden plate now. This acts as more or less a half, or a partially sort of silvered mirror. So some will get through and microwaves will get through, some microwaves will be reflected. So watch this and listen and try to work this one out. I'm going to put the wood close to the metal screen. So we've now got two layers. We've got a half silvered, if you like, or partially reflective mirror, transmitting some microwaves, reflecting some, and then we've got this metal sheet which reflects behind. Now listen to this as I move the wooden screen and the metal screen apart. Listen carefully. Here we go. Here's the microphone. So hopefully you can hear the change in intensity. We're getting maxima and minima. It's another interference effect. So the last setup I'd like to show you is called Lloyd's mirror. So I'm going to hold the microphone again next to the speaker. And you can see I've got this reflective surface. So the waves are being, some of them will be going across to the reflector directly, some of them will be reflecting off and hitting the detector. So let's move this across and listen very carefully. So it's a decrease in intensity. Maybe a slight increase. A decrease. We're getting more again. Then a decrease. So we're going to get another mini maximum. Maybe. Okay, so you can see we were getting fringes there as well. Yet another interference effect. So for both those last two situations, try to think about what's going on. You might like to draw a diagram. Okay, I hope that's been interesting. Just a different way of seeing wave phenomena in action.